Hi, I'm Samantha McGovern, and welcome to a brief review of astronomy throughout time.
The Mesopotamians lived over 6,000 years ago. The Mesopotamians built observatories known as ziggurats. These observatories had 7 terrace levels, each representing wandering celestial objects. Their astronomers were timekeepers. They kept track of yearly cycles for agricultural purposes. The Egyptians also lived 6,000 years ago. The Egyptians used astronomy to chart their calendars and prepare for Nile floods. They also used it to align their buildings with north, south, east, and west, and the rising and setting of the sun. The Chinese, 13th century BC.
They recorded observations of eclipses as well as meteor showers, guest stars, and comets. This enabled them to accurately determine year length and is still used to help guide research today. Thales, 624 to 547 BC. He was the first Malaysian astronomer and was taught by the Egyptians. He is most famous for predicting a solar eclipse that occurred during the battle between the Lydians and Persians in 585 BC. Pythagoras, 582 to 500 BC. He developed a solar system model. Celestial bodies moved in circular paths, and celestial objects were shown as spheres. Pythagoreans discovered that the Earth was round. They also believed that planets created a celestial harmony that because we are so used to, we can't hear. Babylonians, 500 BC. They scientifically marked the beginning of astronomy. They started off by charting motion patterns of the moon and planets, as well as planet rotation length. They also strongly believed in astrology. They tracked the planets constantly to predict weather patterns. They even had mathematical descriptions for planet motions. Aristotle, 384 to 322 BC. He proved the Earth was a sphere and that all celestial motions must be circular. He had 3 ways of proving the Earth was a sphere. The first was that all falling objects moved towards the center of the Earth. The second was that the shadow of the Earth on the moon during a lunar eclipse was circular. Third and final was that certain stars can and can't be seen in certain parts of the world. Aristarchus, 310 to 230 BC. He applied geometry to the study of astronomy. He used it to find the distance and sizes of the sun and the moon. His formula for angular diameter was theta equals 206,265 times linear diameter divided by distance to an object. His formula for distance to a body was distance to an object equals 206,265 times linear diameter divided by theta. Eratosthenes, 276 to 195 BC. He used geometry to calculate the size of Earth and found Earth's circumference and the distance from one place to another. Hipparchus, 190 to 125 BC. Hipparchus was able to find the distance to the sun and the moon. The moon was 59 Earth radii. He created a systematic catalog of brighter stars and even discovered a new star. He also found movement of celestial equator with a pole move. Mayans and Mesoamericans lived 1,000 to 2,000 years ago. They aligned their buildings with sunrise and sunset at the equinox and solstices. They also kept track of Venus. Many of their gods were identified with Venus, and they even timed battles to coincide with its positions. They kept track of its positions by aligning buildings, and the building lines of sight pointed towards the northernmost and southernmost risings of Venus. Ptolemy, 127 to 151 AD. He was the last great astronomer of antiquity. He completed a system that could accurately account for the motions of the planets. He also invented terrestrial latitude and longitude and gave coordinates for 8,000 places. Ptolemy was also the first to give maps north at the top and east at the right. Arabs and Muslims. Many Islamic astronomers were not Arabs, though they wrote in Arabic, but they did improve the way planetary motions were calculated and named several stars, which are still used today. Their most important contribution to astronomy was the rebirth of Western astronomy by helping translate Greek works, astronomical research, into Arabic, which preserved the ancient works for later research. They were also the first to create observatories like modern counterparts. They used measurement instruments, timekeeping devices, and libraries of over 400,000 manuscripts. Copernicus, 1473 to 1543. He proposed the first fully developed heliocentric model of the solar system. When he found two errors in the Ptolemaic model, he was motivated to create a heliocentric model of the solar system. These two models were 1. Placement of the planets didn't agree with recent observations, and 2. He accepted Plato's idea that the planets must consist of two uniform motions of circles. He also discovered that you can determine all planetary distances in terms of Earth's orbital distance, the AU, astronomical unit, through use of geometry. Brahe, 1546 to 1601. Though he ironically opposed the heliocentric model, he ended up providing evidence that supported the model as being true. He believed that the heliocentric theory was wrong. He looked for stellar parallax but failed to detect it, because they were too far away and would have had to be larger than the sun, so he believed the Earth didn't move. This theory was wrong. This led him to create a model of the solar system where the sun and the moon orbited Earth, but everything else orbited the sun. He was also the first scientist to understand the value of multiple observations of the same event. He constantly made observations of all celestial objects rather than only at specific times. He even made his own instruments for observation, though he made them from metal instead of wood. This made his observations more accurate. Galileo, 1564 to 1642. He was alive during the invention of the telescope and used it for all of his observations. His star observations, he discovered the Milky Way was a combination of myriad stars that were so faint and close together they couldn't be seen by the naked eye. He also noticed that stars remained the same size when magnified. These observations dismantled Tycho's reasons for denying the heliocentric model of the universe. For the sun and the moon, he observed that the moon had mountains, valleys, and plains, and discovered the sunspots and their motions. When he observed Jupiter's satellites, he discovered 4 satellites that orbited Jupiter, which helped demonstrate Earth was not the center. Kepler, 1571 to 1630. He was a colleague of Brahe for the last 2 years of Brahe's life and inherited his research, which helped him solve the problem of planetary motion. There were 3 laws of planetary motion. The first was all planets move on an elliptical orbit with the sun at its focus. The second is that planets move so an imaginary line connecting the planet to the sun sweeps out equal areas in equal intervals of time. The third states that the squares of the sidereal of the planets, P, are proportional to the cubes of the Semenjar axis of their orbits, A. The formula is P squared theta A cubed. Newton, 1642 to 1727. Sir Isaac Newton was an English physicist and mathematician who invented calculus. He also discovered the laws of gravitation and the laws of motion. The first is, an object at rest tends to stay at rest, and an object in motion tends to remain in motion unless stopped by an external force. The second is, a force causes acceleration of an object. Force equals mass times acceleration. And the third and final is that for every action there is an equal and opposite reaction. He also discovered that sunlight is made of all different colors and created the spectrum. Edmund Halley, 1656 to 1742. Halley was an astronomer and mathematician that first calculated the orbit of the comet later named after him and predicted its return in 1758. Einstein, 1879 to 1955. He created the theory of relativity, which had two parts. The first was special theory of relativity, which deals with whether rest and motion are relative or absolute. The second is the general theory of relativity. Deals with the revision of Newton's theory, shows that objects continue to move in straight line in space and time, but we observe the motion as acceleration because of the curved nature of space and time. Niels Bohr, 1855 to 1962. He discovered the structure of an atom and developed the Bohr atomic model. It showed that electrons travel in a set and orbit around the nucleus. Wolfgang Pauli, 1900 to 1958. He developed the Pauli exclusion principle, which stated in an atom, no two electrons can occupy the same quantum state at the same time. Werner Heisenberg, 1901 to 1976. He developed the uncertainty principle, which explains that it's impossible to know where something is and how fast it's moving at the same time. Edwin Hubble, 1889 to 1953. He discovered that there were other galaxies and learned that the farther away a galaxy was, the faster it appears to move away. This formed the basis of the Big Bang Theory. George Lemaitre, 1894 to 1966. He was the father of the Big Bang Theory, which proposed that Earth began with a single quantum. He found this by applying his new general theory of relativity to the universe as a whole. Robert Oppenheimer, 1904 to 1967. He was the father of the atomic bomb, but later regretted doing it and wanted to take it away. Fred Hoyle, 1915 to 2001. He discovered nucleosynthesis, which means that elements are created in a star. Penzias and Wilson. They developed the theory for cosmic background radiation. Armstrong and Aldrin. They were the first men to walk on the moon.